In 2019, Nvidia was worth about $80 billion. That was fine. Respectable. About the same as a mid-sized airline. Nobody was writing think pieces about it. Nobody was worried. 5 years later, Nvidia crossed $3 trillion in market value. $3 trillion! That is more than the entire GDP of France. More than the United Kingdom. More than every person, every factory, every export, every government contract produced by the fifth largest economy on Earth in an entire year. And Nvidia does not make cars. It does not drill oil. It does not grow food or build hospitals or run a military. It makes chips, very specific chips, that most people will never see, never touch, and would not recognize if you handed one to them. So how does that happen? How does a company that fits inside a few warehouses in Santa Clara become worth more than the output of entire nations? That is the question, and the answer is stranger than you think. To understand what Nvidia is, you first have to understand what it was. For most of its life, it made graphics cards, GPUs, hardware that rendered video games. If you played PC games in the early 2000s, you probably argued with someone about whether an Nvidia card was better than an ATI card. That was the battlefield. The company was good at it, but it was a niche business. Gamers, enthusiasts, a specific sliver of the technology market. Then something unexpected happened. And it did not happen loudly. It did not happen with a press release or a product launch event. It happened quietly in university research labs around 2012.
Researchers discovered that the same hardware Nvidia built to render explosions in Call of Duty was extraordinarily good at something else entirely. It was good at matrix multiplication, at running thousands of small calculations simultaneously, in parallel, at enormous speed. That turns out to be exactly what machine learning needs. Not a little bit, completely, fundamentally. The architecture of a GPU is almost perfectly shaped for training artificial intelligence. Nvidia did not invent AI, but Nvidia built the engine that runs it. And when the world decided it needed AI at industrial scale, there was really only one place to go. Here is how this actually works in plain terms. When you train an AI model, what you are doing is running the same type of calculation billions of times over an enormous data set, adjusting tiny variables each time until the model gets good at whatever you are asking it to do, recognizing faces, translating language, predicting the next word in a sentence. A regular CPU, the chip inside your laptop, does this sequentially. One task, then the next, then the next. It is very fast at each individual task, but it can only do a few things at once. A GPU does something different. It has thousands of smaller cores, all running simultaneously. It is not faster per calculation. It is just doing vastly more of them at the same time. For AI training, that distinction is everything. NVIDIA's flagship product right now is called the H100. A single H100 chip costs somewhere between $25,000 and $40,000, depending on availability. And you do not buy one. You buy racks of them. You buy clusters of thousands. The big AI labs are spending billions of dollars just acquiring the hardware to train their models. OpenAI runs on NVIDIA. Google's AI infrastructure runs largely on NVIDIA. Meta, Amazon, Microsoft, all of them are customers. All of them are competing to get more chips.
Now, here is where it gets interesting. NVIDIA does not manufacture its own chips. It designs them. The actual fabrication is done by TSMC in Taiwan. NVIDIA is, at its core, a design company with extraordinary engineering and an almost unchallengeable position in the software layer that sits on top of its hardware. That software layer is called CUDA, and CUDA is the real moat. CUDA has been around since 2006. It is a programming platform. It lets developers write code that runs directly on NVIDIA's hardware. For nearly 2 decades, the entire AI research community has built on top of CUDA. Every framework, every library, every model organization has been optimized for it. The collective knowledge of how to build AI systems is, in significant part, NVIDIA knowledge. Switching away from NVIDIA is not just expensive in hardware terms. It means rewriting software, retraining engineers, abandoning years of institutional knowledge. For most organizations, that cost is prohibitive. This is what economists call a switching cost, and in NVIDIA's case, it is nearly a wall. AMD makes competing chips. Google has built its own AI hardware called TPUs. There is real investment in alternatives.
But none of them have cracked the ecosystem problem. The moat is not just the chip. The moat is that everyone already knows how to use Nvidia's chip, and nobody wants to learn a new language in the middle of a technology arms race. So you have a product that the most powerful companies in the world urgently need. You have no real alternative at scale, and you have a 20-year head start in the software that everything runs on. The result is pricing power that most businesses can only dream about. Nvidia's gross margins crossed 70% in 2024. For a hardware company, that is almost unheard of. It is closer to what you see in luxury fashion or pure software. They are essentially selling shovels during a gold rush, except they also own the only mine where you can get the right kind of shovel.
Now, a fair question. Is any of this real? The stock market has a long and distinguished history of pricing things into the stratosphere before gravity eventually reasserts itself. Cisco in 1999, General Electric in 2000, every railway company in the 1840s. The pattern is not subtle. There is a version of this story where AI spending is a bubble, where the returns never materialize at the scale the market expects, where companies eventually pull back on infrastructure spending and Nvidia's revenue flatlines. That risk is real. Nvidia's valuation requires not just sustained growth, but extraordinary sustained growth for a very long time. The math does not work otherwise. And there are some cracks. Nvidia's customers are simultaneously its biggest threat. Google, Amazon, and Microsoft are all building their own custom AI chips. They are not planning to be dependent on Nvidia forever. They have the resources and the engineering talent to develop alternatives. It will take years, but they are working on it. There is also concentration risk. A significant portion of Nvidia's revenue right now comes from a small number of very large customers. If even one or two of them slows down their infrastructure spending, the effect on Nvidia's numbers would be visible immediately. So the question is not whether Nvidia is genuinely important. It is. The question is whether the market has already priced in a future that may not unfold exactly as expected. Step back for a moment. Nvidia's rise is a story about being in the right place, with the right product, at the exact moment the world decided it needed something you had been quietly building for a decade. That looks like genius in retrospect. It always does. The more interesting question is not how Nvidia got here. It is what happens when the world figures out it cannot afford to depend on any single company this much. That answer is still being written, and depending on how it turns out, the story of Nvidia is either the beginning of something or a very expensive lesson about what happens when one choke point controls everything. We have been here before. We just never paid this much for the chips.